Protein requirements in post-operative period. Nutritional status is one of the important parameters that decide the course of post-surgical recovery. The concept of nutritional status in surgery involves various aspects of perioperative nutrition that includes both preoperative and post-operative nutritional status. Many studies show that preoperative acceptable nutritional conditions help to prevent early and late post-operative complications. Kineo published a study in 1996 that compared two groups of patients, a previously malnourished group and another in agreeable nutritional condition. Both groups had undergone elective lumbar spinal surgery. It was reported that out of 26 post-operative complications, 24 were in the malnourished group. Based on the study findings, the study authors recommend that close attention should be paid to the preoperative nutritional status of patients undergoing surgical procedure. The researchers propose that individuals with suboptimal nutritional parameters should be supplemented and replenished before elective surgery. Similar studies done indicate that the conclusions can be generalized for any kind of operations. Hence, special considerations should be given to malnourished and undernourished cases. Successful recovery from a surgical intervention depends on many factors, and post-surgical nutritional support is one of these. Post-surgical nutrition should be initiated as soon as possible. The improved nutritional status helps in wound closure, improving immune responses, preventing infections or sepsis, and preventing immediate and late complications. Proteins are a source of amino acids, the basic building structure of the body. Owing to this property, adequate protein intake is essential for proper wound healing. Protein depletion appears to delay wound healing by prolonging the inflammatory phase, by inhibiting fibroplasia, collagen and proteoglycan synthesis, and by inhibiting neoangiogenesis, proliferation phase, and wound remodeling. Surgery poses great metabolic stress on the patient, with the severity of the stress depending on the severity of the wounded site. An injured patient requires more protein than a non-injured patient because of the increased metabolic activity of wound healing, acute phase protein production in response to stress, and amino acid mobilization from muscle used for hepatic gluconeogenesis. Experimental protein depletion in animals showed a decrease in the tensile strength of wounds. In a study of 108 human patients with experimental wounds, individuals with either low serum protein or serum albumin had significantly weaker wounds than those with normal protein values. Protein-calorie malnutrition increases morbidity and mortality in the surgical patient. Many studies have found hospitalized patients in a state of malnutrition at admission. Thus, it is important to increase protein intake to optimize healing and immune function, and to prevent post-surgical complications in these individuals. Protein requirement. In a non-injured state, adults require approximately 0.8 grams of dietary protein per kilogram of body weight per day. Elderly patients have a higher protein requirement, 1 to 1.2 grams of dietary protein per kilogram of body weight per day, due to a decreased ability to synthesize proteins. A surgical trauma patient can require significantly more protein. Minor surgery may not significantly increase the protein requirement. However, if the patient is already protein malnourished, wound healing will be adversely affected unless dietary protein intake is increased. Major surgery can increase protein requirements 10%, while a patient with multiple traumas may need 75% more protein. Special cases like burn wounds cause tremendous metabolic stress and have the greatest impact on protein requirements. Increasing protein needs 75 to 100%. Therapeutic modes of nutrition. Patients in whom the protein requirement of the body outweighs the intake, supplements are required to meet the increased demand. Therapeutic modes may be helpful in this case. Oral nutrition is safest, cheapest, and best. Enteral tube nutrition may be used in patients with a functioning gastrointestinal tract to supplement oral feeding or to replace it entirely. The latter is indicated for patients who require intensive protein support. Partial parenteral nutrition supplies only part of the patient's daily nutritional requirements, supplementing oral intake. TPN, total parenteral nutrition, supplies all of the patient's daily nutritional requirements. A peripheral vein may be used for short periods, but longer periods of use with concentrated solutions can readily lead to thromboses. Monitoring of weight, plasma proteins, glucose, etc. should be done regularly. Role of milk proteins in recovery process. Whey proteins are an excellent protein source for everyone, no matter what their age. From a nutritional perspective, whey proteins reign supreme. Whey is a byproduct of the cheese and casein manufacturing process. It contains approximately 20% of the original milk proteins. Exciting new research is being conducted that indicates certain whey protein components help provide the growth of new body tissue. Biological activities include immune modulation and anti-inflammatory and healing effects. Casein is basically a milk protein and is considered the major protein component of milk. Caseins are a family of phosphoproteins synthesized in the mammary gland. They possess immune modulator activity and can influence gut motility. Caseins are extremely high in the amino acid glutamine, which is the most abundant amino acid found in skeletal muscles and may play a role in supporting the immune system.